Welcome geometry students to class today on this Friday. Yay, we love Fridays. Friday, April 4th. Hope you guys are doing well. Hope you guys are ready to learn some math today. Some quick announcements. These announcements are always important, so please listen carefully. We will have probably, now usually I tell you for sure, this is not for sure, but we're looking at probably a quiz on Tuesday and probably a chapter 10 test on Friday, more than likely, okay? All right, now, we've got some problems with homework here, okay? So, 2 out of 5 students turned in Wednesday's homework, Azu and Martin. Now, here's the assignment right here. Please look. Page 560, 10 through 23. Now, you didn't have to complete the whole assignment, but I told you you had to turn in what you did in class. Now, normally, I would email your parents right away, but I'm going to show a little grace and mercy since you guys have done so well in keeping up with your homework. I need 3 students, Haley, Jake, and Jasa, to turn this in. Now, if I don't have it in my box before the day's over today, when I get to school, then I will have to email your parents over the weekend and say, hey, I didn't get Wednesday's assignment from your children. So please keep that in mind. I think maybe, Haley's, that might be the day you were leaving early. So again, like I said, I didn't email any parents. I'm giving everybody an extra day, but let's get this turned in today. Okay, it was actually due yesterday. So Azu and Martin, you're good. Haley, Jake, and Jasa, please turn in Wednesday's homework. Now, let's talk about last night's homework, okay? Everybody needs to turn in last night's homework. Everybody, okay? And last night's homework is right here. Page 561, 27 through 29, 31 through 34, and number 38. So here's the video for us. So I'm not mad. I'm just concerned because I'm not going to let you guys not turn homework in. It's got to be turned in. You've got to practice this stuff. You've got to go over it, and over it. So all of you need to turn in this assignment right here. It's due today. Okay, this is what you did yesterday, and I did not get that from anyone, so no one turned it in early. So everyone needs to turn that in now, and then 3 of you, let's see, Jake, Jason, and Haley, I need this assignment right here. This was due Thursday, and I did not get that from you 3. So I want all of this turned in today, or I will be emailing parents over the weekend, okay? Now, if there's any problems, you know I'm not a mean person, contact me via email or phone call, whatever. And if there's something I need to know, just let me know, okay? But please take care of this. Jasa, you took the test. Thank you. I appreciate that. I will grade it over the weekend, and I will post your grade on Sycamore, and then your third 9 weeks should be completely finalized, okay? All right, that's it for announcements. Let's take a quick second and review this week's material so far. So here we go. Don't forget, we've talked about how to solve and simplify a square root. You should know how to do that. We have talked about solving 45, 45, 90 triangles. Leg equals legs, hypotenuse equals square root of 2 times the leg, and the leg equals the hypotenuse divided by the square root of 2. So you should know this. You should know how to solve these. If not, you'll want to go back and review this. We have talked about solving 30, 60, 90 triangles, and students, you should be able to do this. Here's your 3 formulas that you use for a 30, 60, 90 triangle, okay? So you should know how to do this. We talked about finding the sine and cosine of an angle when given a right triangle. You should be able to do that. Opposite over hypotenuse for sine and adjacent over hypotenuse for cosine. You should be able to type these into your calculator. If you are struggling with any of this, then you're a little behind. You need to go back and make sure you know how to do this. Then we talked about finding the tangent of a given angle when you have a right triangle. You should be able to do that. Tangent of an angle is opposite over adjacent. And then we talked about typing these into your calculator, okay? You should be able to do this. Then we talked about using tangent to solve for the missing side of a triangle. We could not use Pythagorean's theorem because we don't know 2 sides. We could not use 45, 45, 90 formulas. We could not use 30, 60, 90 formulas. So we use tangent. Tangent of 22 is opposite over adjacent, and then you would multiply both sides of this equation by x over 1, and then I'm not going to work the whole problem out for you, but we did that yesterday. So you should be familiar with how to do this, okay? If not, you need to go back and watch this and make sure you know how to do it. This is so important, okay? And I think on Monday I'm going to give another review day, and I won't do this every Monday, but just like this past Monday, I gave you guys a lot of notes and you turned your notes into me and we just reviewed the whole hour. I might do that on Monday to really make sure we're getting all of this information, okay? So I'm thinking about doing that. Okay, now yesterday we solved for missing sides of a right triangle by using the tangent ratio. Remember that? We did that yesterday. However, what if we have a scenario like the one below? Please watch this carefully. Circle this angle, go straight across. This is your opposite side. Here's your right angle, go straight across. This is your hypotenuse side. And then over here, the leftover side is your adjacent side. Now, if you went to use tangent like you did the other day, you would say tangent of 50. Oh, look at the problem we have, students. Look at this. Tangent of 50 equals opposite over adjacent. We don't know either one of those two sides. We'll call the opposite side OP, and we'll call the adjacent side X. We don't know either one of those two sides, so we have two unknowns. So in this case here, in this scenario right here, you couldn't use tangent. You couldn't use Pythagorean's theorem. You couldn't use your 30, 60, 90 formulas. You couldn't use your 45, 45, 90 triangles. You couldn't use tangent. And so what are we going to do? Okay? So I'm trying to show you there are some cases or some scenarios where you can't use your tangent ratio. So today we are going to learn how to, we are going to learn how to use the sine and cosine ratios to solve for missing sides of right triangles. Okay? Now, your heading then would be using sine and cosine to solve right triangles less than 10.5. And by the way, you know by now I go fast. It's easier for you to pause the video than to speed it up. Okay? So there's your heading, there's your lesson number, and there's your date. Now, by the way, don't forget our little helpful kind of memory thing that we use here, SOHCAHTOA, okay? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. That's really going to help you as we get into solving these problems, okay? So let's go ahead and try some problems and see how we do. It's not going to be a very long video today, and you're going to have 8 problems in your homework, so they're not that long, but I really think you need to focus on really understanding your homework, okay? So here we go. I would like you to copy this triangle in your notes. I would like us to solve for x. Now, first of all, realize we cannot use Pythagorean's theorem because we do not know two sides. We cannot use our 30, 60, 90 shortcuts. We cannot use our 45, 45, 90 formulas. So we're going to have to circle this angle they've given to us and go straight across, and this will be my opposite side. Then go to your right angle and go straight across, and this will be your hypotenuse, and your other angle has to be your adjacent side. Now, in this case here, you could use tangent. Let me say that again. In this example here, you could use tangent. Okay. In fact, you're going to have to use tangent. So I wanted to start off with one by showing you that sometimes you'll use tangent. Well, Mr. Earhart, how did you know if we're going to use tangent or cosine or sine? Well, here's how I knew. First of all, I circled my angle and I labeled all 3 sides. Do you see that okay? Then next, I look at one of the sides that I know. This is the side that I know. And I look at the side I'm trying to solve for. The 2 sides are called opposite and adjacent. Let me go over that again. I circle the side that I know, and I circle the side I'm solving for. And the 2 names of those 2 sides are opposite and adjacent. Now think about your SOHCAHTOA. Which one of these has opposite and adjacent? Tangent does. This one doesn't. This one doesn't. So the only one that I can use is tangent. So that's how I know which trig ratio to use. So I'm going to go ahead and write down tangent of 43 degrees equals opposite over adjacent. And now this is just like yesterday's work. This will be a nice review of yesterday's math. Now when you solve this, I taught you guys yesterday, look at your denominator. It's an x, and whatever your denominator is, that's what you multiply the entire equation by. So your denominator is x, so I'm going to put x over 1. Now x times tangent would be x tangent 43 degrees. X over 1 times 8 over x, your x's would cancel, and you're left with a 1 here and a 1 here. So 1 times 8 is 8. 1 times 1 is 1. 8 over 1 is just 8. Now we're solving for x, and notice x is not by itself, so we're going to divide both sides by tangent of 43 degrees. Okay? Divide both sides by tangent of 43 degrees. Now these will cancel out, and you're left with x equals, now make sure you type this into your calculator correctly, 8 divided by tangent of 43. 8 divided by tangent of 43, and you will get 8.57894968. I'm going to round to 2 decimal places, so I'm going to put 8.58. So there, we found the length of our adjacent side. Okay, it goes right here. So there it is. All right. So what I want you to start getting used to is knowing. Are you ready for this? I want you to start knowing whether or not you're going to use tangent or sine or cosine. And that's what we're going to practice now in these next 2 problems. So take some really good notes, and I think I'll be able to help you. Okay? Copy this in your notes, please. Now we're going to solve for A and B. Okay? So the first thing we do is we realize we have a right triangle. Can we use Pythagorean's theorem? I would like to, but no, we can't. We don't know 2 sides. Do I have a 30, 60, 90 triangle? No. Do I have a 45, 45, 90 triangle? No. So what I'm going to have to do is try to use sine, cosine, or tangent. So I'm going to circle this angle. I'm going to go straight across. This is my opposite side. Here's my 90 degrees. Go straight across. This is my hypotenuse. And then the other side is your adjacent side. So everybody should be pretty familiar with how to label your 3 sides. We've done that a lot, okay? Now, here's the thing. Mr. Earhart, do I use sine, cosine, and tangent? Well, here's what you do. You circle your known side, which is this side here. You know the hypotenuse has a length of 7. And then you circle one of your unknown sides. Now, I don't care which one it is. You can solve for A first, or you can solve for B first. It doesn't matter, okay? I'm going to solve for A first. So I circle A. So students, would you please tell me, what 2 sides am I dealing with? I'm dealing with hypotenuse, and I'm dealing with opposite. Do you see that? I circled these 2 sides. I'm dealing with hypotenuse, and I'm dealing with opposite. So what trig function deals with hypotenuse and opposite? Well, let's see. So, ka, toa. Well, this side deals with opposite and adjacent. I don't want that. This one here deals with adjacent and hypotenuse. I don't want that. This is the one I want. Sine deals with opposite and hypotenuse. So I'm going to use sine. So I'm going to say sine of 34 degrees equals opposite over hypotenuse. There it is. I set it up. Now I'm ready to solve this. Remember, next you look at your denominator. It's a 7, so I know I'm going to multiply the entire equation by 7 over 1. Now 7 times the sine of 34 is 7 sine 34 degrees. And then 7 over 1 times A over 7, your 7 would cancel with your 7. 1 times A is A, 1 times 1 is 1, so we have A over 1, or just A. And look at that, A is all by itself. So you know A equals this right here. So all you have to do is type that into your calculator. So I'm going to type in 7 sine 34 degrees. And your answer will be 3.914350324. Now I'm going to round it to 1 decimal place. So I'm going to say A equals 3.9. Okay? So I'm going to come over here and I'm going to put 3.9. Now you have a choice, students. Do you now know two sides of this triangle? Yes. So could you, is it a right triangle? Yes. So could you use Pythagorean's theorem? Yes, you could. I'm not going to, but you could. What I'm going to do now is I'm going to use hypotenuse, I'm going to use cosine to solve for b. I'm going to use cosine. So watch how I do this. Cosine of, what angle do we have? 34 degrees. What does cosine equal? Adjacent, which is b, over hypotenuse, which is 7. There we go. Now, my denominator is 7, so I'm going to multiply both sides by 7. 7 times cosine of 34 would be 7 cosine 34 degrees. And then 7 over 1 times b over 7. Your 7's would cancel. 1 times b is b, and 1 times 1 is 1, so b over 1 is just b. So look, b is all by itself. So all that I have to do is type this into my calculator, and I'll know what b equals. So 7 cosine 34 degrees. 7 cosine 34 degrees would give you 5.803263008. I'm going to round to one decimal place, no certain reason, I'm just going to, and your answer would be 5.8. Okay, so now we know what this side is, 5.8. All right, there we go. So we found the missing sides. Let's try another one of these, and then I'm going to turn you guys loose on your homework, okay? So let's try one more of these. Okay, let's solve for x and y. X and y. Now here we go. Do we have a right triangle? Yes, we do. Can we use Pythagorean's theorem? No, we don't know two sides. Do we have a 30, 60, 90 triangle? No, we do not. Do we have a 45, 45, 90 triangle? No, we do not. So we're going to have to use sine, cosine, or tangent. Well, remember the first thing you do is you circle your angle, go straight across, and label all of your sides. Okay, there we go. Adjacent, hypotenuse, opposite. Next, we decide whether we're going to use sine, cosine, or tangent. So remember, the first thing we do is we circle the side that we know, and then we circle the side that we're going to solve for. In this case, I'm going to solve for x. Now, could have you solved for y? Most definitely. I just happen to choose x, so I'm solving for x. Okay? So, let's go ahead and look at what two sides we circled. Let me go over that again. You always circle first the known side. You have to do that. And then you choose what other side you want to solve for. You very well could have chosen y, and that would be fine. There's nothing wrong with that. All right. Now, look at the two sides that you chose. You chose adjacent and hypotenuse. Which one of these three ratios has adjacent, right here, and hypotenuse? This one. So it's cosine. So we're going to say cosine of 65 degrees equals adjacent, which is x, over hypotenuse, which is 12. And now notice your denominator is 12, so we're going to multiply the entire equation by 12 over 1. 12 times cosine of 65 would be 12 cosine 65. And 12 over 1 times x over 12, your 12s would cancel. 1 times x is x, 1 times 1 is 1. So you have x over 1, which is just x. And look at that, x is all by itself. So all that we have to do now is take our calculators and type in 12 cosine of 65. And you will get 5.071419141. So I'm going to go ahead and round that to 5.1. 5.1 is x. Okay? Now, I'm going to go ahead and put 5.1 here. Now, do I know the measurement of two sides? Yes. You know this side and you know this side. Could you use Pythagorean's theorem? Yes, you could. I'm not going to. I'm going to practice my trig functions, but yes, you could. Now, I'm going to use sine to finish this problem up. And Mr. Arrowhead, how did you know to do that? Because I'm looking for the opposite side. And I know sine has opposite. Well, Mr. Earhart, tangent has opposite also. You're right. And you could use tangent. Tangent would work also. In fact, I think I might just do that and show you. You'll get the same answer either way. So I'm going to use sine, and I'm going to use tangent, and kind of watch what happens here. This is really neat, okay? I'm going to use both of these and show you it works, okay? All right, the sine of 65 degrees equals opposite over hypotenuse. There we go. Now, our denominator is 12, so we're going to multiply both sides by 12 over 1. 12 times sine of 65 would be 12 sine 65 degrees. And 12 over 1 times y over 12, your 12s would cancel. 1 times y is y, 1 times 1 is 1, y over 1 is y. So look at that. I can now type in 12 sine 65, and I will get out 10.87569344, or in other words, 10.88. Now, I'm going to show you could also use tangent when you're trying to find this last third side. Watch carefully. Tangent of 65 equals opposite over adjacent, 5.1. Okay, now my denominator is 5.1, so I'm going to multiply both sides. Let me move this over a little bit. I'm going to multiply both sides of my equation by 5.1 over 1. Well, 5.1 times tangent would be 5.1 tangent 65, and then 5.1 over 1 times y over 5.1. Your 5.1 would cancel with your 5.1. 1 times y is y, 1 times 1 is 1, y over 1 is y. So now with my calculator, I'm going to type in 5.1 tangent 65, enter, and I'm going to get, now it's off just a little. Instead of getting 10.88, I'm getting 10.94. But do remember something. We rounded the 5.1. It was really 5.0714191441. So there is going to be a little room there for error, and I would not take off for either one of these answers. They're both totally acceptable. But I just wanted to show you when you're trying to solve for that very last side, you could use sine or tangent. Either one of those would work because both of them have opposite in their ratios. Sine has opposite right here, and tangent has opposite right here. Okay, so that was totally fine to do. All right, now I hope this has made sense. If you're a little confused, you might want to back it up and watch different parts of this again. Okay, it's totally up to you. Here's your homework assignment. I want you to do page 567. Numbers 25 through 32. That's 8 problems. Numbers 25 through 32. Now, the video that I'm circling right here over and over, this video, like I say so many times, is from last year. Here's the name of the video that goes with your homework. This video is from last year. So don't worry about anything that you hear that talks about quizzes coming up, tests coming up, homework being due a certain day. Ignore all of that. Ignore that. This video was made last year. The only thing that you're listening for in this video right here is how to work out the problems. Okay, so please don't forget that. Now also at the very beginning of the class period, I mentioned to you guys that some of you owe me homework. You might want to work on it now if you don't have it done, because this assignment right here is not due until when? Monday, so you could always do it over the weekend if you had to. Just don't forget to do it, okay? Because if this trend continues where homework's not being turned in, then I won't give you an extra day. I'll just email your parents right away. So those that are missing assignments, at the very beginning of the class period, we talked about that. Maybe you'll want to work on those now and get them done so you can turn them in before the weekend, okay? That's totally your decision. All right, call or email if you have any questions. I hope you guys have a good day and a good weekend, and I hope this video has been a help to you.